So hello everyone, welcome to week 9 of Bioethics 400, Responsible Conduct of Research. As always, what we're doing in this course is we're exploring the 8 different topics of research integrity or responsible conduct of research as defined by the U.S. Office of Research Integrity, and this week we're focusing on the issue of peer review. We're actually going to get the opportunity in this course for you guys to act as peer reviewers, in that we're going to have you each read and give comments back on a draft of another student's research project. But what we're going to focus on right now is simply what the expectations are around peer review, as well as issues of responsibilities of peer reviewers and editors during the process. So our learning objectives are twofold. First is to give you guys an understanding of the importance of peer review in the scientific process, as well as to examine the peer review process itself and explore the responsibilities of the reviewer during that process. So let's start by exploring what peer review is. So peer review is a system of external expert review, and it's important for ensuring the validity of scientific research as a form of quality control. And peer review has actually been used since the 17th century, but it became increasingly common in the 19th and 20th century. And in 1937, the requirement for peer review for awarding grants from the National Cancer Institute was written into public law. Now, all major funding agencies today require peer review of grant applications, and a majority of journals also use a peer review system for submitted manuscripts. Finally, personal and professional advancement is often based on the ability to get articles published in peer-reviewed journals, to get grants, and thus peer review is also an important part of the promotion and tenure process. So not only do you have to go through peer review in order to get the publications and the grants that you need in order to even be considered for promotion or tenure, but in addition, a peer review system itself is used for the promotion and tenure process, wherein a committee of your peers, usually faculty members as well as external experts, are asked to review your contributions to both the scientific literature as well as your research and service to the community in order to make a determination about whether or not you actually deserve to get a promotion or be granted tenure. Now, peer review the process of peer review also depends on the idea that because so much of academic inquiry is specialized, peers with similar expertise are the best judges of the quality of the work. Who else but a researcher active in the field could evaluate the originality, methodology, and contributions of other investigators? Peer review also improves the quality of a grant application or a paper. Finally, it's particularly important in scientific research because scientific publications are not just another set of opinions, as I like to say. It's not like an op-ed piece or the opinion that you espouse while talking with your friends over a beer on Saturdays. Rather, it has direct import for, say, clinical care or health policy. And so it's important that these be critically evaluated because they're much more important and much than claims made by folks like politicians, newspaper columnists, celebrities, or even campaign groups. Science is considered to be a search for the truth, and so it's important that we make sure and verify any claims that are made publicly through a process like peer review. Now, the peer review process takes place after manuscript, for example, is submitted to publication. In that case, the editor may send the paper for review by members of the journal's advisory board or to a few external reviewers who have expertise on the subject of the article. And sometimes it's actually a multi-step process. Sometimes you have an executive or a managing editor who reviews the manuscript initially and makes a determination about whether or not it even fits within the scope of the journal. And then they might assign it to a member of the editorial board, who again reviews the paper and makes a decision about whether or not it deserves to go out for an external review. And once that happens, then the journal editor will make a decision to send it out for review, and they'll ask people to comment on a variety of things, including, as I mentioned, the manuscript's validity. That is, are the results credible? And did the researchers use the appropriate study design and methodology? They're also asked to judge the significance of the findings. Is the paper important? Does it contribute or advance the field? And they're asked to determine the paper's originality. Are the results new? And is it properly referenced and built? Does it build upon the work of others? Now, there are different types of peer review that are used, and the three most common types are listed here. The first is called unblinded or open review, and this is a system in which both the authors and the reviewers know each other's identities. So a paper is sent to a reviewer, and it has the author's names and affiliations directly on the manuscript. And then when the peer reviewer writes the review and sends it back, when that is provided to the authors for response, the reviewer's name is also included on that. So it's a system in which both the reviewers and the authors know each other. Now there's a single blind system. This is used by many scientific journals in which the authors do not know the identity of the reviewers, but the reviewers know the identity of the authors. That same approach is used for review of grant applications, for example, in that one of the criteria that a member of a grant review section will consider is the qualifications of the investigators. So it's important that a reviewer of a grant know who the submitters are. However, the grant applicants don't know who specifically reviewed their grant application. They may be able to find out a list of the reviewers on the study section, but they won't be able to attribute any specific comments to that individual. And then finally, there's a double-blind peer review system. This is where neither the reviewers or the authors know the identity of the other, and this is probably the most commonly used system. It requires a little additional work on the part of the editor because they are required to redact from the paper any information that could be used to find out the identity of the author or the institution at which the work is done before they send it out to the peer reviewer. Sometimes, in fact, it can be considered impossible to actually properly blind a paper in this regard. When I was the executive editor of the American Journal of Bioethics, for example, I received a manuscript for review that talked about the ethical process that was used to review experiments that led to the creation of the first so-called humanized mouse. That was a mouse that was made in a laboratory at Stanford University in California, in which they were engineered to have human-like neurons in their brains. And so obviously, when I sent that manuscript out for review, there was no way to properly blind the paper. That is, I could not take out information about the institution or the authors simply because no other institution, no other research group had actually had actually humanized mice before. So there was no way that the reviewer, no matter how carefully I redacted the manuscript, there was no way that the reviewer wouldn't know that this was a paper that was coming out of Stanford University. Now, peer reviewers are expected to provide the editor with a document that states the problem of the research, puts the research into perspective, notes whether appropriate credit has been given to the field, comments on the originality of the work, describes whether the research design is adequate for the conclusions written, and says whether the grammar is correct and the writing style is understandable. So each reviewer sends comments back to the editor, who then considers them and makes a determination as to whether or not the paper should be accepted as is, accepted with revisions, or rejected. And again, the primary criteria that are used are the validity of the paper, the significance of the paper, and the originality of the paper. Now, peer reviewers themselves have very specific obligations, and these include punctuality, professionalism, confidentiality, respect for intellectual property, and a disclosure of conflicts of interest. And so we're going to go through each of those. So punctuality is also known as responsiveness, and that is the idea that reviewers should complete their reviews within a stated deadline. Preparing research reports and grant applications takes an enormous amount of time, and any delay could actually hurt the author or the applicant professionally. If the reviewer can't meet the deadline, he or she should decline to perform the review or should inform the appropriate party of the problem, for example, the journal editor or the study section head, so that an accommodation can be made. Now, reviewers are also expected to show professionalism and competence. So a reviewer should accept a review assignment only if they feel that they have the adequate expertise to provide an authoritative assessment of the paper or the grant. If a reviewer is unqualified, they may end up accepting a submission that has deficiencies or reject a paper or a grant application that is actually quite worthy of publication or funding. Now, reviewers should also provide useful comments for improving a proposal or a paper, and these comments should avoid any insults, attacks. You really don't want to give an author or a grant applicant a review that essentially says something like, "This is the worst paper I've ever read." Rather, you want to give the applicant or the author a peer review that actually help them improve the manuscript or the grant application and thus improve the quality of the science that's being either published or funded. Peer reviewers are also expected to respect confidentiality. That is, that any material reviewed is treated as confidential after the completion of the review, and that you have the expectation that reviewers will destroy any proposals or papers that they have in their possession. Moreover, the material under review is privileged information and should not be shared by anyone outside the review process unless doing so is necessary and is proved by the editor or the funding agency. There are some exceptions to confidentiality, however. For example, if a reviewer becomes aware, based upon a reading of a grant application or a submitted manuscript, that his or her research may be unprofitable or a waste of resources, it is considered ethical to discontinue that line of work. What they can't do is they can't actually act on the information that they received in the peer review, but they can at least discontinue current lines of inquiry that they know are going to be ineffective. Okay. Now, when this is done, however, that peer reviewer should communicate to the individual requesting the review, for example, the study section or the journal editor, that they plan to do this. Okay. Moreover, every effort needs to be taken to ensure that a reviewer is not taking advantage of information garnered through the review process. Now, if a reviewer is unsure about confidentiality questions, they should ask the appropriate party, for example, the study section officer or the journal editor. What they shouldn't do is they should never share any information with anyone outside of the peer review process. This includes sharing, privileged materials with colleagues or with students, even if this is done as part of a teaching exercise. The only time that you're allowed to share these materials outside of the peer review process is by actually contacting the appropriate party, the journal editor or the program officer, and asking permission to do so. An example of when you might do that is, let's say I'm reviewing a manuscript on how well human subjects review committees manage conflicts of interest, and the paper purports to have conducted surveys of IRB members and does detailed statistical analysis. If that statistical analysis is outside my area of expertise, I might go to the journal editor and ask for permission to share the relevant sections of the paper with a biostatistician in order to determine whether or not the statistical analyses used seem valid. But I can't do that until I get the permission of the journal editor, and then I can only share information that is appropriate or sufficient. Similarly, and you'll actually, in many of my courses, I actually do something like this. I actually get the permission of an author of, say, a grant application or the author of a human subjects protocol. I get their permission to use it as a teaching tool in some of my classes. So when we undergo the peer review process later in this course, each of you will be asked to give permission to share your paper with another student. Should you decline to give that permission, then you will be excluded from the peer review process. So you won't get any feedback on your paper, but similarly you won't get the opportunity to actually do peer review. So I will ask your permission to share your confidential drafts of your paper with one other student. On the other hand, I also expect each of you to abide by confidentiality provisions during that process and not talk about what you read or use that information in order to improve your own paper. Confidentiality even extends to the idea that I should never inform someone that I reviewed their manuscript or their grant application, because doing so is a violation of the provisions of the peer review process. Reviewers also need to show respect for intellectual property. That is, they should not use any of the property or information that they get from reading a submitted manuscript or grant application without the explicit permission of the authors. This includes respecting another's ideas and making sure we don't plagiarize their ideas or their words. Finally, there has to be disclosure of conflict of interest. Researchers need to be as objective as possible in considering the article or application under review. They need to ignore any possible personal or professional biases. Now, if a reviewer has a potential conflict of interest, be it personal, financial, or philosophical, which could interfere with the objective review process, they should either decline to be a reviewer or to disclose any potential biases to the editor or the granting agency. So I do a lot of reviews for the U.S. National Institutes of Health, and during the review process, I am initially given a list of grant applications and including the names of the applicants and the institutions they're from, and I'm asked to identify anyone for whom I feel I might have a potential conflict of interest. And there are actually rules that have been established by the NIH. For example, you cannot review the manuscript or can't review the grant application of anyone with whom you work with directly, who works at your institution, or with whom you've published in the last 3 years. Now, it's a little harder when you in some of the scientific fields, because some of these individuals you may consider to be your colleagues, but you may also consider them to be your personal friends. So you have to make sure, even if you don't work with the person directly, if you do have a friendly relationship with them, to ask yourself whether or not you believe that you can actually review that individual's application objectively, and if you can't, you should identify that conflict and recuse yourself from the review. And so often, because of how small the bioethics community actually is, when I'm reviewing bioethics applications for the NIH, I often find that I recuse myself from about a third of the applicants being considered, either because of personal relationships or professional relationships. Now, I love this quote from Richard Horton, the editor of The Lancet, because he was asked about peer review, and he stated that editors and scientists portray peer review as a quasi-sacred process that helps make science our most objective truth teller. But we know that the system of peer review is biased, unjust, unaccountable, incomplete, easily fixed, often insulting, usually ignorant, occasionally foolish, and frequently wrong. Now, this is the editor of one of the top biomedical journals in the world, and he, like most scientists, acknowledged the problems with the peer review system, but they still believe that the advantages of this system outweigh the disadvantages. Peer review often improves the quality of research presented in a paper or grant application, although research about the peer review of articles, research on peer review itself, shows that it remains unclear who's responsible for this improvement. Is it the editors? Is it the peer reviewers and their comments? Is it the associate editors who often copy edit papers? Is it biostatisticians who reviewed the work? Or is it the author themselves who during the revision of the manuscript? Now, the scientific enterprise has sustained itself using peer review, as I mentioned, for quite some time, over 3 centuries now. Given its faults and all of its problems, we still believe that very few breaches of ethical behavior during the peer review process have actually occurred. Now, researchers themselves are well aware of peer review's problems and often ask what the alternatives are to peer review. So would it be simply having a journal editor decide what should be published? Would it be having the government decide who should be awarded grants? Having everything published without a way of distinguishing between quality and nonsense, i.e. publishing on the internet? And awareness of the problems inherent in the process of peer review, such as the potentials for biases or the appropriation of information, which we'll explore in the next slide, often helps people avoid falling victim to the lapses in ethical actions. So Richard Horton is correct in that peer review is a terrible system, but it reminds me, in fact, of a famous quote from Winston Churchill when addressing the House of Commons shortly after the end of World War II, proclaimed that democracy is the worst form of government, except for all of the other forms of government that have been tried from time to time. So we know that there's problems with peer review, but it seems to be the best system that we have. So what are some of the problems with peer review? Well, as a quality control mechanism, peer review has many, many problems, okay? It's slow and expensive, it's biased, it's open to abuse, it doesn't sometimes catch simple mistakes in research and even misses egregious cases of plagiarism. And in research that's looked at the peer review process, there is often low agreement between reviewers, suggesting that they have either personal or professional biases, okay? So reviewers have biases that sometimes they're unable to disregard when they read a grant application or paper. And such biases can include disagreement with the methods used in a paper or grant. There have been many times when I've actually got reviews back in which the reviewer's comments is essentially saying that I used the wrong methodology or statistical method. They may have a dislike for the author or an applicant's institution. That's why blinding of papers is so important, because it helps them avoid issues around author-related or prestige-related bias. Prestige-related bias refers to the likelihood of someone giving a more favorable review to a paper or a grant application that is written by someone who is a well-known luminary in the field or who works at a top institution like Stanford or Harvard. But it can be something as simple as even gender bias. There are studies that show that manuscripts that are in which the lead author or the majority of authors are women actually have a lower frequency of acceptance than manuscripts that are submitted by men. And there was a very famous scandal a couple years ago in which a reviewer actually commented to the authors of a paper that they would do better if they included at least one man in what was prior to that point a solely female authored manuscript. Now, you also have situations where the bias can be professional, where the individual is in direct competition with the author or grant applicant. This is a fundamental problem because journal editors, study sections want to make sure that the paper is being reviewed by someone who is an expert in the topic or the methodology, but often those individuals are actually themselves working in the field, so it can become very difficult to identify a peer reviewer who is not seen as a competitor of someone who's submitting a manuscript for publication or a grant for funding. Now, peer review also has the problem in that it may not allow for controversial or innovative research to enter the literature or to be used as the basis for a grant application, because reviewers often subscribe to the prevailing paradigm. So their professional biases, their intellectual biases, may lead them to reject a manuscript that goes against the conventional wisdom, even though it seems to be correct. And this falls into, if any of you have taken a philosophy course, the idea of Thomas Kuhn's concept of scientific revolutions. That is that a theory or a hypothesis tends to dominate within the scientific community until there is a sudden paradigm shift. And so for years and years and years, researchers will be locked into a single concept or an idea, and it's only when that concept, that theory, that hypothesis can no longer be supported by the bulk of evidence that you'll suddenly see a shift in the conventional wisdom. And so we're seeing a lot of those shifts currently if you look at, say, biology, for example. There used to be this prevailing paradigm that genotype determines phenotype, but now we recognize that there are epigenetic changes that influence how genes are expressed, and so you can actually have two identical organisms, but epigenetic changes, responses to the environment, can lead them to express very, very different phenotypes. Similar examples were the idea that DNA goes to RNA, which goes to protein, and there would never be a system that would reverse that. But we know, for example, that retroviruses, which are RNA-based viruses, actually get converted to DNA and insert themselves into the genomes of their hosts. So there are plenty of examples in which that conventional wisdom has been overturned, but it often takes many, many years because the peer review system is inherently biased against novel ideas or controversial ideas. You also have problems in that peer reviewers may not be forthcoming in admitting any conflicts of interest that they have in reviewing a paper or grant application, or they may be reluctant to admit a lack of experience in reviewing a manuscript or an application for research funding. Finally, you have issues of errors. Peer review process usually doesn't find errors in research, and that is in part because the authors themselves are biased in how they write a manuscript, and they only present analyzed data, aggregate data, and often try to either purposely or in the interest of space, they tend to disregard any data collected that doesn't necessarily fit their hypothesis. Now, this is not always misconduct, a topic that we'll discuss next week, but sometimes it can lead to the information being presented in the manuscript not being an accurate representation of the research that actually occurred. And had it been an accurate representation, the peer reviewer may have picked up on an important methodological or statistical error. Now, what are some other problems? Well, other problems in the peer review process, you tend to have an emphasis on positive results because these are viewed as more exciting than negative results and thus are more likely to be published. You also have bias towards English language publications. Most of the scientific journals, at least the ones that are read globally, are published in English. And so you have, obviously a bias towards English language publications, but you also then have a bias towards native English speakers and writers. And so sometimes you have excellent research coming out of labs overseas, but because the researcher themselves is not a native English speaker, they might not be able to present their ideas or their concepts as clearly in English as a native speaker would, and so that can lead to a manuscript being rejected, not because of the content, but because of the way it's presented. As I mentioned earlier, editors do ask for the reviewers to give them feedback on whether the grammar is correct and the language itself that's used is clear and consistent. So let's actually go through a couple examples. Let me show you an example of how bias may affect a peer review. So let's just consider the following study abstract. This is redacted, but it's an actual abstract. Okay, the objective of this study was to determine whether an intervention for hospitalized cardiac patients would reduce overall adverse events and their length of stay. And what the researchers used was a randomized controlled double-blind placebo parallel group trial. That's a lot of complex words, but essentially what it means is that hospitalized cardiac patients were randomized to receive one intervention or the other, and neither the researchers nor the cardiac patients themselves knew which treatment they were going to receive, and then they compared the two groups, those that received standard treatment and those that received the experimental treatment, with regard to how well they did in the hospital and how long they stayed in the hospital. Okay? And they actually did a pretty large study. This was 990 consecutive patients that were newly admitted to a coronary care unit. And the main outcome measures, as I mentioned, was time to discharge, and this was done by looking at their charts. And what they found was 524 people were in the usual care group, and 466 were randomized into the experimental group. And those that were in the experimental group had a lower mean, sort of CCU course scores. What that means is how well they did in terms of their recovery in the CCU and the number of adverse events that occurred while they were in the CCU. So the experimental group actually had a lower frequency of adverse events associated with their cardiac issues, although the length of their stay in both the coronary care unit and the hospital was not different. So the conclusion was that this particular intervention was associated with better outcomes within the critical care unit, and so it, as the authors write here, suggests that the intervention may be an effective adjunct to standard medical care. Now, if you simply looked at this study abstract, I would actually probably say that this is a well-designed, well-controlled study that found an important statistically significant outcome. So the actual manuscript is this one. The intervention itself was intercessionary prayer, or praying for others. And what they did was they actually randomized individuals admitted with cardiac events to a coronary care unit to receive remote prayer done by a prayer group in which the names of the patients were given to the prayer group who prayed for them daily for 4 weeks. Now, the patients weren't aware that they were being prayed for. The doctors were not aware that these individuals were being prayed for. And the people praying for them did not know and had never actually met the patients. In fact, they didn't even go to the hospital. This was all done at a church in the same town, but remotely. And so you can see how even though the intervention in this case was prayer and the experimental group was the patients not being cared for, this automatically, for many people, will raise personal biases because they can't imagine how, particularly those who are not, say, devout Christians, they can't imagine how someone praying for another individual at a distance and not even knowing that person could actually lead to a better clinical outcome in the coronary care unit. Instead, most people would just say this is likely to be statistical noise. And so if I received a manuscript like this, I would automatically be biased against the manuscript because it goes against my beliefs that prayer may work for individuals, but that intercessionary prayer by others from outside seems to be unrelated to medical outcomes. So this is just an example of how a peer reviewer's personal biases could potentially affect how they actually reviewed and commented on the manuscript. And so I just want to close with another peer review case study for you to consider. And this is a case study of Professor Smith, who has a very active and productive research laboratory with several graduate students and postdocs. And one of the things that he wants to do is help them develop their communication skills by making them give talks in group meetings and seminars within departments, and also presenting at meetings and writing various reports and papers. Now, like me, he also wants to teach his students the peer review system, and so anytime he gets a peer review manuscript for peer review from an editor, he actually asks one of his graduate students or postdocs to review it as well, so that he can teach them the peer review system, and also perhaps they might pick up on something on the paper that he didn't catch. In fact, there's some interesting studies that suggest that the best peer reviews don't come from well-known people in the field, but actually from junior faculty who really put a lot more time and effort into the peer review itself. And so he allows his graduate students and postdocs to peer review manuscripts, and in fact, as this states here, some of his postdocs have become quite skilled, and so their reviews actually don't need any editing before he signs them and sends them to the journals. So what are some of the ethical issues in this case that arise? And so obviously some of the things that should automatically occur to you are the idea that Dr. Smith, though he's trying to actually do something good for his students by giving them exposure to the peer review process, is actually violating a number of the roles and responsibilities of the peer reviewer. For example, he's violating the confidentiality of the peer review process. He's also taking credit for the work of others. We haven't talked about plagiarism yet, but we will next week when we go over scientific misconduct. But he's by submitting the reviews of his postdocs with no editing under his name, he's actually taking credit for their work and misrepresenting his role and responsibilities to the journal. Finally, there's questions about fairness to the trainees that perform reviews, because he's actually putting them in a tenuous spot by asking them to violate the ethical responsibilities of the peer reviewer. So there are actually several things wrong in this very straightforward and simple case study. So with that, I'm going to end, and I look forward to seeing you guys all on the discussion board. Remember that we'll actually be engaging in a peer review process in a couple weeks, so take the time to read through the assigned readings, look at these slides carefully, because I'm going to expect that your reviews meet and uphold the same standards as we've just talked about. And I'll also give you a specific peer reviewer sheet that I'm expecting you guys to complete. All right, so I'll see you guys all online. Bye-bye.